And again, thanks everyone for showing up to these. A lot of what this is me just describing some of the month to month the developments that are made on this, and also giving an opportunity for anybody to ask questions about the lathe engraver. So I'm going to spotlight myself for everyone. That way, it'll help me make sure I have the right camera view on, and Rob will always let me know when I have the wrong camera view on. So thank you for that.
Would I do that?
Yes, you do, and I very much appreciate
You're very
the
welcome.
effort that you put into that. Just at the top, again, I'm going to be at the AAW meeting in Raleigh with Lathe Engraver. I'll have a table there. I'm going to be running a deal there, which is that I have a limited number of pre-built kits, and this is what I've done at all the symposiums. Pre-built kits at the kit price. So that's like, I don't know, like a 400 something dollar saving from that. So you could, if you're interested, you can pick up one at AAW from me there. Also, we had talked about previous months, Thursday night at AAW getting together and having some beers. And we're just going to play that one by ear. So if you come by my table at some point on Thursday, if you're there, we'll figure out what's going to happen. Okay. Usually what I do is I start with software and go through all of the latest updates that I've done. Because there's some new people here, I'll also give just a brief description of the things that I'm talking about. It's going to be brief, but it will maybe provide a little bit of context for this. So, first and foremost, this interface here, this is the software interface, and what you see kind of in this view is all coming from the Lathe Engraver plugin for Octoprint itself. Octoprint is the host control software that is sending all the commands from a computer to the control board, and that all happens in this particular interface. So some of the things that I added or talked about last time was the ability to do multiple runs. I'm going to increase the size of this a little bit, so you'll probably see that a little better there. The ability to do multiple runs. So if you have a G code file, which are all the instructions that you're going to send from the computer to the control board, if you hold down the control key and click the start button, it'll give you the opportunity to run this multiple times. And as I mentioned, one of the things that I wanted to add here was the ability to inject commands between runs. The idea here is if you're doing something that's repetitive, that you're gonna do it multiple times, and say you're gonna do it every 20 degrees, you could have all of the commands that you need. You're gonna do that however many times, 8 times, or whatever the number is that you're gonna have, and then you can actually inject some rotation, for example, between all of those. So that's active now, and that should be working. Um,
Hey, Paul.
yes.
So that could, if it was simple, it could take care of continuous print. Is that
Yes, that's the idea is you can completely remove continuous print now, and use that instead. And I don't know if you've run into issues with continuous print, but I think with one other small change that I'm about to have, it eliminates all of the problems where continuous print would occasionally miss a run. So I figured out why
uh
that is.
No, that's good. So you just put in there A90
Um, you'd have
in the intervening command, say,
Yeah, it
if you
has
want to
to be
rotate.
a valid G code command. So you would have to give it, for example, G0A90. So
Got it. Yeah, yeah,
it
yeah.
does
Same as what's in the continuous print thing.
that's right. Yep,
Yeah,
same as a
yeah.
continuous print. So you
Cool.
and you can give multiple commands. So you just would give put a comma between each of the commands that you're going to send.
I see. And sorry, how did you get to that?
So what you do now is you hold down the control key on the keyboard and click the load and start button.
I see.
Or if you have the G code already loaded, if it's, you can see here now it has that file name there. If you hold down the control key and click this start button, it'll also bring up the same menu there.
Thanks.
Yep.
A quick question. Is anybody else having issues with this being blurry?
It even looks a little blurry on my end, but I have
Yeah,
no idea why.
it's blurry on my end. Yeah.
Yep.
Okay.
Is it
All
super
right.
blurry?
It's not
The left
horrible.
the left column is horrible, the middle one's not as bad, and the right one is fairly clear.
I have no idea why it's doing that. All right, let me let
It's
me
on a tilt or something. I don't know.
let me try something else. This
Yeah, I was
is
about ready to jump off and jump back on, but I wanted to ask first.
all right. So my camera stops. Preview, new window. This still kind of doesn't look right to me, but I'm gonna just try and do it as a screen share instead. Now
Oh, much better.
I got to figure out how to hide video panel.
What
Uh,
what was the answer?
I think I was just getting the wrong window selected. It was way down at the bottom of the list instead of the first, or I might have had two projectors open. I'm not sure. Either way,
Okay,
hopefully that's better
much
overall.
better.
Okay. Though now I don't remember what I was talking about. So we did
Or,
multi-run.
yep, that's what we were talking about.
Okay. The other thing which is added now, which should be very helpful for people, is having this feed hold button, which is right here. So we talked about this last time. I have physical feed hold buttons and restart buttons. Um, the problem that you run into is that Octoprint has a pause feature, but that pause feature just stops sending commands. So anything that is already in the buffer on the control board will continue to be sent. So a pause isn't an immediate pause. Now this feed hold button acts as a true pause. So if I just run something, you'll see now two things happen. One is that we have an e-stop button, so that's a virtual e-stop, which will stop everything. Or I can click this feed hold, and now that you can't see that, I mean, it was moving, but now it's in a state of hold, and there's no motion happening. And that happens immediately after you push that. And then you can just click restart here, and it'll start the operation again.
So
So
is
it's just kind of moving.
the
Well, you can
difference
actually
between
see a percentage increase there too and stop and start when you hit the button.
What was that?
You can see the percentage of the job completion
Oh,
start
yeah,
and stop there. That was cool.
that that's not that's how much of the how many of the commands have been sent. That's not necessarily how many have been executed. Just as a warning for that.
Okay, so that was filling the buffer then.
Yeah, that's how much it's gone to the point where the buffer's been filled.
Would it help if you change the color on the feed hold button when it was engaged?
Uh, if I change the color, it does change the
Yeah.
text. Right? So if I run this again, it has feed hold here, and then you click it, and oh well, there might still be some bugs in the UI of this because it did change it, but yeah, it's not flipping. Here you can see it's now at restart, but it's functional at least at this point, I think. So, and you can do an e-stop. So you can see here, I just clicked the e-stop, and now we get an alarm. One of the things that will happen after an alarm is that it will go into this pause state, and you can, for example, now cancel that job there. And once you come out of this, you'll be in the alarm state because you did an emergency stop. So then you have to do an unlock here, and you can't see that on the screen. Uh, you can you click unlock, and then you can confirm that unlock, and that'll take you out of the alarm state. So,
That E hold saved me twice this morning. I'd never seen it or used it, um, and, but this morning it saved me twice when I hadn't zeroed out
oh
my
yeah.
XYZ before running something
So you
because I
can
don't have the physical buttons.
yeah, you can start the job and then move the mouse right over here real fast to make sure it's going to work the way you expect it to.
So would I use feed hold or e-stop? I mean, I used e-stop. I didn't even notice the feed hold.
Yeah, well, I mean, you can e-stop will force you to reset, and go back to the beginning. Feed hold in that. I mean, if you know that the job's not going to work the way you want, you can do the feed hold and then cancel the job, and that will do the same thing basically. But either one will
Yeah,
stop the motion immediately.
yeah, great addition.
All right. So there's a change in the scanning plugin. So this
Paul,
is
before we move away from the feed hold, is that
sure.
only available on that one screen or is it on other screens too?
Right now it's only available on the control screen here. I have considered putting it up in the top bar as well. That would make it available all the time.
Yeah, I
Um,
like that.
it's a little bit tricky to work in this navigation bar, uh, but I think it should be doable. I just
Is it
haven't looked into it yet.
is it on the pop out?
It will be on the pop out, yeah. So if you, I should do that and verify it. I didn't actually. Yeah, it's there on the pop out as well. I don't know that I've tested it from the pop out, but since it just clones everything that's in here, it should work as expected. I will have to go back and test that, make sure. Okay, the small change to the scanning plugin. This is a more of a coming soon thing because I haven't pushed the change yet. So just for those that aren't familiar with any of these things, the scanning plugin is how you can get the profile of a bowl or whatever your workpiece is. That you can do some operations with. And I thought I would actually run through using the profiler plugin. So I'll do a scan and do a facet sort of setup and a small walkthrough. I'll start a little bit of the cutting and then I'll just do a feed hold and I'll finish it up later on because it'll be a long job. But the change here is that there is now the ability to create, along with an STL file, which gives you a three-dimensional model, you can create an SVG directly of the profile. So that can be useful for things like in the Rose Engine plugin, where you can, for the curvilinear or other operations, if you're going to follow a profile, you can get an SVG file from that directly. You don't have to do anything else. So that and all it does is it adds in the scans folder where it writes the text file, it'll also write an SVG file. That's a fairly minor change. The Again, a good bulk of the work has gone into the Rose Engine plugin. And for those that aren't familiar with this, this is all of the things for ornamental turning. So things that emulate functions of the Rose Engine lathe or various components for ornamental turning like eccentric chucks and geometric chucks and all of those things. So this is definitely one of the most complex plugins. And I know I saw Justin was on here. Justin's been doing a lot with this and giving me a lot of feedback on that. So I've really appreciated his contributions and including a plugin, which we'll talk about in a minute. Um, the main changes in this are in this eccentric offset. So what this does is you load a rosette and let's see, let's just pick this one. This is just an A8 rosette. So there's 8 basically bumps on this. And the eccentric offset will set it off center. So this functions like an eccentric chuck. So if I told this to be off 10 millimeters, um, I can reload this now. So, and now you can see that the center of rotation is actually moved over 10 millimeters. What wasn't functioning previously was it was really complicated to have the eccentric offset and then make, for example, concentric designs that went around. You would usually change that by changing the amplitude of this, but these two things didn't work together. At, I think I did one meeting where I tried it and it just failed miserably. But now those do work together. The only catch with this is that it changes the behavior a little bit in that if you've used this at all, you didn't have to adjust the amplitude. That would happen at runtime, but now you have to adjust the amplitude before runtime. So these two things work together, and I can now just click this, and you can see it's changed the amplitude of this. So, and along with this, I've made some small UI changes. It's moved these radii measurements off to the left here. And if you use a pumping rosette, it moves those radii measurements off to the right here. Just makes it a little clearer. But what this does is this lets you do concentric offset, if that makes sense. What did I do with that? So that's what I've done here on the top of this box. And this is maybe not a good choice for the direction I did it since the grain is going this way, but still that was just it was a very straightforward thing to be able to do once I made those changes. And it was much more complicated before. So and that's just a little you know, kind of a throwaway ornamental thing. I was testing this is with pumping, so changing amplitudes with pumping, and this has some threading that was done on this as well.
That is a fantastic looking piece there, Paul.
Oh, thank you. I wish I would have put a little more time into you know, doing like these beads nicely, but I was just playing around, which is what I mostly do these days. I mentioned UI changes. Yeah, so and again, I think I already said this, but to reload a rosette, you know, in the past you'd have to go to like a different rosette and then come back to this one, but you don't have to do that anymore. As you make changes to this, you can just click on the same rosette and it'll reload that same rosette with any of the eccentric changes or the amplitude changes.
Oh, we're still seeing the platform. Are you?
Oh, yes, yeah, I'll do that again. So again, I don't have to modify. I don't have to select something different. I can just select the same rosette again, and it'll load up again.
So
I've
you're
also
so in order to get that concentric rosettes there, you are simply just adjusting the amplitude.
just the amplitude. Yep.
Gotcha. Cool.
So that'll keep the center that many millimeters off of the center. Um,
So
I have also go ahead.
are you changing the amplitude of the entire piece or the amplitude of the pattern when you do that?
It changes the amplitude of the pattern. So if I eliminate this, we're at 1 here. It changes this difference in radius is what it changes. So you know, this is 2.5. So if you have a rock amplitude of 2, that will make that a 5 millimeter difference between that 0 point and whatever the lowest point is.
Okay.
So it is an amplitude coefficient. I think that would be the proper way of saying that.
So as you
Oh,
increase the rock amplitude, it gets smaller in radius then.
No, as you increase the rock amplitude, the overall radius is going to increase. So that is a difference in the previous versions. So the previous version, I could set this rock amplitude to 2, and it wouldn't adjust these things at all. All it would do was it would increase that difference, and you had to calculate it yourself what the difference was. But now it will actually give you, if you want to make that exact pattern right there, then you have to set the starting maximum radius at 50.8. Does that make sense?
I'll have to play with it, but no, it doesn't make sense right now to me.
So again, remember all this ever does is it is going to make this R, and I added this R diff here because that's really the important thing. So if I start this at the half radius, right, at 25.4,
I see now.
and I run it as it is with that amplitude here, it's just going to, well, heck, why don't we just do it?
Perfect.
We
So
got time.
basically, you're taking the average of your R max, R minimum, and it's just then the difference is the plus or minus from that.
Right. So hold on. I think all you really care about is the difference because that's all it always I'm putting a paper check on here real quick. My pen. This ball over here. And I'm just going to estimate center. That's one of the nice things about using this 3D printing sheet is that I lined up the tick marks on here with the center, so I can get a fairly reasonable estimation of where center is. So I'm going to set the z-axis here to 0, and if I go to the Rose engine view here, so let's just do it first. Let's set this to 1, not 11. So 25.4. So I would, for example, set this to 25.4. And so we're at the max radius now. And we can click start and then drive the pen in here. I got to go in a little more. Let's make it go faster. All right. Oh, darn it. Okay, I did 0A at some point. Now, if I do the rock amplitude at 2 here and I reload the rosette, right? Max radius is 50.8 and our R diff is 5.1. But if I don't change the radius position here and I run it, all you're going to do is you're going to have, right? Your starting position is always going to be the same. And you're just going to be now have that difference in amplitude.
And that's what you did on the lid of that box?
No. Well, I mean, yes, but in that case, I had the eccentric offset set. So I'd moved it off, and then all I had to do was and I didn't change. I changed the radius every time, so that they were at concentric. Right. This is not concentric in this case because I didn't move it over. But if I were to move that over the other 25.4, right? I think that puts me at 25. Yeah, close. Um, and I ran this, then my difference in amplitude between those would be what we'd expect, which would be would still be the 5.1. Oh, I went in too far there. I'd forgotten to reset in between those runs. That's why it went further. But does that make sense? Right? Why this is the difference between this and this now is that 5.1, and the difference between this and this is also 5.1.
Yeah.
It just depends on what your starting radius is.
Yeah, that makes sense.
Okay. Sorry, I felt like that was kind of a long explanation for something fairly simple, but what else do I have?
Thanks
Ah,
for doing that, Paul. That really helped.
no worries. Um, geometric chucks. Save geometric chucks. You can now change the name. I know Ed asked about that last time. So if you have a geometric chuck, you do have to load it first, but now once it's loaded, if you right click on that, you can give it a name. And now that will be selectable from the list here. So, so I think that's all of those things. And I'd mentioned, let me go to full software view here. Justin's here, and Justin has created a plugin now that works with Octoprint, which is a rosette generator. So, and I did use this one in order to make rosettes to do that box, I think, to get the appropriate mount. So, you've got, and maybe I'll let him talk about this if you want to. I don't want to put you on the spot, Justin, if you don't want to, but you can select different styles of rosettes. You can set the radii here of that outer radius, amplitudes of these. I'm using a trackpad, so I'm having a little problem sliding these things, but
Yeah, it's
number of segments.
definitely a work in progress. The standalone one is a little better with the UI, the limitations with the Java and stuff, but
Yeah, well, I mean, I think it's going to be really useful as you continue to do things. And I haven't really played much with the multi. So you can do this hold, which now will sort of set this segment, and then I'm trying to remember how to do this. And
yeah,
then you
so if you
can,
change to like a dip now,
yeah,
Rosette,
yeah. I'm just trying to remember how to. And now you get a second design here, and you
yeah,
can
and then
make
you can hit the
adjustments
merge.
on it, and then click merge. Is that right?
Yep.
And then then you save
That
you
didn't something
can
went wrong then.
oh
Because
yeah.
it should have merged it. Doesn't look like it did.
Okay. Well, and then you can export that as an SVG.
It probably
And
did. It probably means that library, that Shapely library, maybe is not installed because
I
that's the library that's required for it. And I added it to the dependencies, but I haven't got that republished.github yet.
I should have Shapely installed on this. So I won't. I was gonna
Yeah,
go look.
that's
I was gonna go look at the log, but either way, this will be a really nice thing, particularly if you want to make iterate on rosettes. You can do a lot with by just changing amplitudes, but you can't do everything that way. So here I used this bump 6, so that came out of that plugin for a number of those.
and on my the standalone one I've done, I added two more sliders that are a max radius and a min radius. So basically, I guess that would be maybe like phasing on the rosette. So like when it gets to a certain point, it just draws the circle. So you can flatten the rosette
I see.
on the inside or the outside. So hopefully I'll get that over to the plugin.
Cool.
That's called fading, not phasing.
Fading. Yep. Thank you. Yeah.
Yeah, it's good to have the experts here.
I don't know about that because
Oh,
I'm
come
I'm
on.
biting I'm biting my tongue and saying, you know, at least for the rosette shapes that have an actual name, we could refer to them that way instead of bump and dip. But
Yeah, and that's on the to-do list too. I want to recreate all the Holtzapfel properly. I know Bill Ooms' software has them all in there. I got to study his code and try to figure out how he generated the more complicated ones so I can put them in there with the correct nomenclature.
where do you live, Justin?
El Paso, Texas.
Oh, okay. Um, just there are a handful of people that have written Rosette software, and with various names, and one of the guys might be willing to share what he's done, so you could kind of
Oh, sure.
get some leverage off of that. But it's not mine, so I can't just promise.
Gotcha.
And I think that that's, remember, John, that I up until whatever it was last August or something, like I knew absolutely nothing about ornamental turning. So I haven't studied enough yet to know what all the proper things are at this point.
Yeah. And I'm
Getting there.
not being critical at all. I mean, I'm still flabbergasted by the progress you've made with zero background. So, I'm truly appreciative. Others have jumped on board because of it too. So, I mean, it's more, I'm not being critical at all. Trust me.
I understand. No, I mean, I think everybody wants to get to the appropriate nomenclature. It's just it'll just take a little bit of time. I mean, I still don't even know if I'm calling a lot of these. I mean, is this eccentric offset the same as an eccentric chuck? I'm not.
Boy, yeah, those are the things where the way you've implemented things is not necessarily traditionally, it's not necessarily parallel to the traditional stuff. And you've essentially created new versions of mechanical things. And
Right.
so it's sort of a playground. That's why I said I'm not critical of the names or anything like that right now. It's just the functionality, and it's a work in progress. So,
Yeah.
um, and and that was the only thing, like way back when, I think in the first session, I asked about your axes naming, and it's like, I'll cut you all the slack in the world because you're doing this from scratch, but the axes are not the normal names either. So
Yeah, and I mean, I have my reasons for that and why I didn't end up changing it, but it was
right. I know.
yeah,
That's why I said, you know, it's a playground, so to
yeah,
speak.
yeah, for sure. Um, okay, so I thought, I mean, if you have questions about anything, please ask. I'm gonna kind of set up to do a scan. So if anybody hasn't seen that before, I'll run through that, and then I'm gonna do a faceted piece with the profiler that uses four sides. And I'll show you some considerations I have for that. I want to take one to AAW that is like that, and so I thought I would just use this opportunity to set it up. And I can talk through it as I go. So first, I'm going to get rid of this paper check and move things off. And again, as I'm doing this, you got any questions about anything, please ask.
Do any of you guys own a pen plotter or do anything like that?
I do not own a pen plotter.
I mean, it looks like by putting the pen in your tool here,
Well,
you can replicate some of the things a pen plotter would do.
um, I would say yes to an extent.
Right.
Um, Again, this is the one thing that the lathe engraver is designed for is to have just the rotary axis here. And so that makes things a little bit more you can't easily do flat things unless you're doing them directly into the face. So
Okay.
you could use the pen plotter in that sense, but that would be the only location that you could really draw well. I mean, you can use a laser, and the laser will write whatever you want. Um,
I'm more interested in drawings, not text anyway.
right.
But I I think I should get this up and running before I even consider a pen plotter, but I'd like to do the artwork, ultimately.
Well, so what I would say is that this is probably if you want to do the artwork on bowls, I don't think that there's any other way than this machine to really do that with a pen,
Right, right.
right? I mean,
So any object uh, I guess curved in the way a lathe would make. I don't know
Right.
how much it could vary from that.
Yeah.
Yeah.
And actually the what I'm going to run through with these steps here would be the same steps that you would go through if you were going to do some kind of drawing or laser work or anything onto a curved piece. So what I'm going to do first is I have the probe set up on here. And I'm just moving to kind of get it into a reasonable position. Um, So for this particular operation that I'm going to do, one of the things that I need to know is I need to know the diameter wherever I'm going to start measuring. So I did that when it was still on the lathe, and so across this whole thing at the rim here is 205 millimeters. So I need to know that particular measurement. And what I'm going to do is I'll go to the scanning plugin here. And I need to know the distance that I'm going to be scanning as well, how far we're going to be going across here. So actually, before I did this, I probably should have um, done something slightly different, which is I'm going to zero everything here, and then I can figure out how far I actually need to scan by just moving the tool over this probe. And I'm going to go right up to the foot of this, and I can kind of eyeball that. So I'm going to go to 72 millimeters. You can see I'm at 72.33, and 72, if I start at the rim, should get me right down to that foot. So I've put the probe right on this edge here, and I can go to the scanning plugin, and I'm going to do a positive scan. So this direction is going positive. We're going to be scanning along the x-axis, so that means we're going to go this way. You also can scan along the z-axis, but this piece in the shape is really set up for the x-axis. We don't actually have to put the reference diameter in here, but I do just so that I remember. And our length of the scan was going to be 72. And for the increments here, I'll do 4 millimeters. And then every time it scans, it's going to pull the probe back to get it off the piece. And because we're going in a downhill direction here, we don't have to come off very far. And so we'll just call this one May.
Paul, the length 72, is that you pre-measured that as well as the depth of the bowl?
No, that 72 was what I just did where I kind of moved out here and I said, okay, I'm going to go to the bottom of the foot. So
Okay.
I zeroed at the rim and then I moved over till I saw where it was about going to work out. And I was, 72 will get me right down to the bottom.
Okay, thanks.
And now this is where you can create, I'll just go ahead and click the create SVG. So that'll make an SVG file. And you can also do ovality scans. I just turned this thing today, so it's going to be pretty concentric.
A Paul
And
question for you.
yeah.
Are you setting the probe tangential to the roughly tangential to the shape of the bowl for a reason, or
Um, Only yes. And the only reason why I'm doing that is that there's potential if you have a very large shape change that you could run in the sides of the probe, right?
okay,
If I just went vertically like this, if I was coming down here and I was trying to measure right down the bottom of that foot, it's possible I hit the side of the probe into the bowl before I got down to here.
that makes sense. Thank you.
So it's a clearance issue, really more than anything else. And
So
it doesn't,
it doesn't really matter which way you put it.
yeah, the orientation of the probe doesn't matter. Well, with this particular probe, because this is a 3D touch probe, so it'll register the probing in any direction. And so with this set up now, I just click the Start Scan button, and it'll move in, and it'll touch off, and then it'll give us the real-time view of the profile of the piece.
I found that the probe is a little different when it points straight in on a curved surface like that. If it's on the side, it distorts a little bit because it slides a little bit before it registers sometimes. I don't know how to explain that, but I always try to have it so it's going as much straight in as possible, and I think I've found to get better scans, and it may just be my probe, but
Yeah, that might be. I haven't noticed that, but then again, I can't say that I paid all that much attention to it, so it that might be the case. I've always just turned it just for that clearance issue to make sure that I had plenty of clearance. And so now we have the scan here, and again, if we go to the scans folder, you can see that this tells us it's an X scan, and this is the SVG file. So if I download this quickly, and I should be able to open this in Inkscape. I think you can see that there. So now we have an SVG file of that scan directly. And that's all we have to do for the scan at this point. So
So Paul, with that SVG file, can we now take that and do a 3D print, plastic print to create something to hold epoxy in it or something?
um so that would be much easier with the STL. Oops. So if you look at here, you can do the exact same thing, but there's an STL. So that will actually make a three-dimensional file, an STL file for you directly if you check that box.
Okay.
And that's exactly what I've used it for, is to make a shell. You do have to, you know, expand it slightly if you're going to make it as a shell, but it gives you that profile.
Yeah, you want a little bit of clearance on it,
Yep.
presumably. And you got to give enough radius between the two mirrored parts for
Yeah,
whatever is at the
exactly.
bottom.
And the other thing that I typically will do when I've done that, I don't think I have one nearby, is I also, because it will just make an STL of just this profile here, and then it just makes it round.
Yeah,
I will extend the bottom typically like 2 or 3 millimeters past that. So I just grab that face and extrude it out. I usually use Blender to do that. And that way, when it sits, it will always sit a little bit above. And so even if you don't get the perfect expansion when you've increased the size, it'll always sit off of the piece, if that
right.
makes sense. It'll sit higher than the piece itself. All right, so I'm gonna move the B axis to the home position. That looks pretty good. And now in this case, I'm going to go to the profiler plugin, and we're going to do a facet mode. So this creates either facets or scallops. So this is the idea here. So these are facets, and I don't remember. I think this is 10 facets. I think this is the one that I did at the North Carolina Symposium. So it will, by knowing what the diameter was at the rim, it can calculate how much depth of cut it needs in order to make that a flat face. And so the thing that's maybe a little complicated if you think about doing this for, I'm going to open up Inkscape again here real quick, is if this is our diameter of this, and we don't want that to be filled. We do want that. If I'm going to do 4 sides, so the minimum is 3 sides that you can do, but if I'm going to do 4 sides, effectively what you're going to have, and this is a rectangle, not a square, because I didn't quite get it right, is you would be cutting all of this material away to get 4 sides on that. And that's too much. So what you can do is you can actually tell the plugin, there's either a maximum depth that I want to go to, or you can determine how far you actually want that to cut in, so that rather than having this flat across profile, it'll actually just be kind of following this curve. So it's still rounded, but it will be squared off. And I'll show you how I go about doing that. So first thing that we do here is we're going to load that scan. So this was that May scan. So if I load that up, that is the profile of our piece here. And we have to now give it a variety of pieces of information. So that diameter was 205 at the reference point. And so we need to set that. So in this particular case, we can set that diameter reference, and that was our 0, 0 point. So now that says that that diameter there is 205. We need to know our rotation center. So I've got the way that I do this is I measure this out, and that is 64, and then I have a chart here. So I know that that's going to be 146 based on my chart. We're going to do 4 segments. I'm going to set the feed rate at 800. And this is where you could set the maximum depth. So you can't quite see that. Let me go here. If you hover over these, it'll tell you what they do. So for facets, this is the maximum depth that it'll go to. Or if you don't give it any maximum, it'll go to the full depth. And I'll show you what this looks like if I were to go to the full depth first. And the step down is how much it will cut in the maximum that it'll cut. And I do about 3 millimeters is about as much as I push it with a 1/4 inch end mill. And then this depth modifier is another way that you can determine the depth of cut. And this is what I'm going to use in this case. But we'll start with 1 here. You can for example, you can give it a profile that you can follow a particular profile. That's where an SVG file could be used. Here, you can give it the tool diameter, and then the step over here is how much this actually determines how much it's going to rotate every time it does let me go to this view. Every time it does a pass as it's going back and forth, how much is it going to rotate the piece? And the smaller the step over, the longer it's going to take, but the nicer the result's going to be. And I think, Steve, you probably played with that more than anyone else. I don't know what you set for a step over for the things you've been doing with this kind of.
Yeah, I'm around about point 0.2, but yeah, and I actually had a question on that. So it says step over percent, but if I put in a decimal in there, is that a decimal of a percent, or is it?
Yeah, so it shouldn't be a percent. It should be a fraction, right?
Okay, all right. That makes more sense. So it's not point, or if a point 0.3 of.
0.3 is 30%.
Okay,
Yeah.
got it. Okay,
Yeah.
that makes a lot more sense. That was one of my questions to ask you today. Was on my list of questions was to make sure that I was interpreting right. So that percent there is not.
Yeah, that's an oversight because a lot of CAM software does percent, and I kind of followed that, but I ultimately was using decimal.
Okay,
So
all right.
it's fraction of tool diameter. So that's what that means. So
Okay.
that's how much it's going to rotate each time.
So while you're there, so I have a question on. So you're using an end mill there. Um, how does is there a way that you can tell it what shape your router bit is? Is it a ball end versus an end mill?
No, there's no way to do that. And I think it would be really complicated, at least
Okay,
from when I was thinking about it, to be able to do that. I think that this is where you have to get a sense for what it's going to do with the different types of tools, and
right.
then you can adjust these parameters accordingly to try and compensate for that.
Okay.
That's
Yeah,
the best that I can tell you right now.
and that's fine. And I just wanted to is is the assumption that it's an end mill?
No, the assumption is that there is some diameter of the tool. That's all it is.
That's all it
Um,
is. Okay.
So if you're cutting deeper, if you're using a ball nose end mill and you're cutting deeper than the radius of the ball nose, then it's still that depth of the tool, right?
Okay. All right.
But if you're using a flat end mill, then it's just assuming that. Um, it does make it a little bit more complicated when you're like trying to get positions lined up because when you have a flat end mill and you're trying to like get it to position here, you almost never get it to be flat right at the
Right.
bottom. You can get it
Yep.
to be flat all the way around here, but once you get down here, it it just never ends up being quite exactly how you want it.
Okay.
Oh,
Well,
what do you tell it when you're using the router UCF
Uh,
for the
I
tools?
I don't tell it anything.
Okay.
Yeah, it is for if you're using a cutting frame. So you're talking, John, you're meaning about the universal cutting frame, this thing.
Yeah, yeah,
Yeah.
because it's got, that's going to essentially touch at one point, but it's got a really large radius, relatively speaking, way bigger than a ball end mill.
Right. So I have not used that for this kind of operation. Just this kind of operation, right? I'm going to be doing up to 3 millimeter depth of cuts, which that thing can't do.
Yeah.
So I've always done this particular operation with just the straight router.
Okay.
Um, I presumably
And
you could do it. It would just take a really long time,
the
which
term we would use for that in our world is slacker.
well, okay. The other thing is maybe it would be good if you were doing a whole bunch of things with finer features. But because I'm making four what are effectively flats on this, I really don't have a problem coming in and sanding that with a block,
Yeah.
right?
No,
I'm gonna have some striations, and I can just boom, boom, boom. It'll take me 20 minutes to sand it, but
I'm just joking and yanking your chain.
oh yes,
I think the fact that you can rotate the router normal to the surface with the scan, that's probably one of the most valuable features that you've built. And using that with a cutting frame is going to be, it's going to lead to some pretty exceptional patterns.
yeah, and I would love to have more people exploring that and to get more of the feedback on because maybe that is something that then needs to get added, right? You can put the radius of the cutter. Um, that it gets a little more like what Bill did with corn lathe,
Yeah.
and you
But
can even set the angle, right? Things like
yeah,
that.
yeah, but it's a really deep rabbit hole.
Yes, I understand that.
So
I'm pretty.
what's the sandpaper stuff you're talking about?
Yeah. You ornamental guys. All right. So the other thing that I have to do in this particular case, I have to tell it where actually want that pattern to be cut on this profile. In this case, I want to do pretty much the whole thing. So I can set a min and max limit for this. So if I do the min limit first, I'm going to go all the way up to the top of this. And I can go ahead and set the max all the way down at the bottom, or very nearly so. I don't want to necessarily run into the foot of my bowl. I still might here, but I can set those things. So that is how far my pattern is actually going to go. I could set my max here, and it will just traverse that length there. So this is how you set where it's actually going to on this profile, where it
so
will actually make the cuts.
Paul, one of the things I have found helpful is that when I do my scan, I show the foot on my scan. And so when I'm setting my max, I can actually visualize where it will be because it's hard to measure along that curve. So I'll just run my scan just a little bit longer than you did, and I see that step and I just know where it is.
Yeah, I've done that as well. The one thing that I have found when I do that is depending on how much scan you have of the foot, um, it will average the rotation angle for the B, and it will take points on either side of whatever point you're at to average that rotation. And so if you have like a long foot on that and you're trying to get right into the corner, as it's averaging that, I feel like the B angle gets further and further away from what you want.
That's
I don't know if
very
you've run
interesting.
into that.
Yeah, well, that could explain some. That's interesting. I that could explain some anomalies that I've seen. Now that I'll pay attention to that.
I have contemplated setting like a an active profile area and like you could say, disregard everything like less than this and more than this so that it won't use that in the B averaging. But the B averaging is one of those things that I don't feel like great about how it works. It's just an average of some certain number of points, and it smooths things out. There's no doubt about it. But I feel like it also can sometimes, if you have those kinds of things, it can take you away from where you want to be. So
I had assumed that when I put the max in there that that was the maximum of the data that it was looking at, but apparently that's not the case. That's just the maximum travel of the bit.
you actually, I should probably I should look at that. I don't remember off the top of my head.
Okay.
Um, because I know that, for example, you can, well, let me set the zero position on this first. So what I'm going to do is I'm going to move the cutter, and right now I've got the B axis, and this has come up because I did an X scan, which is going this direction. What the software is assuming is that we're going to go to that very first point that we made on here, which is the 0, 0 on our profiler. And that's going to be we're going to set that as our 0 point. And because this is an X scan, the router bit has a B axis angle of 0 degrees because it's going to need to know that that is actually 0 degrees so that it can rotate the tool to follow that profile. So
So when you're setting the router up to the edge, are you going to the center of the bit or to the edge of the bit?
I'm going to go to the center of the bit. Now, if I'm off a little bit in my B-axis angle or potentially even my distance from the end of the router bit to the center of rotation, then you can compensate for that in multiple ways. One of them is to move the position of the 0 point. Top of this. And so that right now, right at that 0. So now this is where I'm going to click all. I'm going to actually click all here and click 0. So everything is at my 0 position now. And to verify that this is where I want to be, then what you can do is you can use this target. So the target in this case is you're going to move the cutter to a particular position. So if I set that to be the target, and then I have to have everything zeroed here first, and then I click go to target, it's going to scoot back, rotate over, set the B angle, and then it'll come up and I'm maybe just a little bit too far in. I'm just touching the surface, and I think that's probably going to be okay because I'm going to be cutting all of the surface anyway. But I'll set the target down here and move it again and see how close it is.
Now, Paul, for a novice, you would want to move the router bit away first and run these practice tests to get your settings dialed in before this, right?
Yeah, or just throw something that is very much a scrap and you're just going to be testing with. So don't do it with your finest piece of whatever it is that you have.
Is there a way to do like an air pass where you do give it an artificial backing up in some place and then say run to just see that it only cuts air?
Not really. I mean, you could set the 0 position off of the piece, and it would effectively, at least for the first couple of passes, it's definitely going to miss, right? If I set my 0 to be here, then everything should be off by essentially the same amount. And as you go, you can verify that it's going to be moving at the speed you want and things like that.
Yeah, I guess that's what I was asking. Would it offset completely from your scanned curve, including the B, if you just change the distance off at the start artificially?
I don't know. Let's try it.
Yeah, that's kind of what I meant. Like if you set your Z 2 millimeters away from the piece, then you should have if it's perfect, you'll have 2 millimeters going the whole, a 2 millimeter gap going the whole profile.
Yeah, I do that a lot in CNC where I just artificially set the Z axis, but there I don't have a tool that's rotating and doing other things.
The
But just being
rotation
able
might, no, the
yeah,
rotation should stay the same, I think. So let's give it a,
I use a 2 millimeter thick stir stick as a feeler gauge. So I set zero using that's 2 millimeters, essentially 2 millimeters off the surface, and I use the set target at multiple points, and I use that feeler gauge to check where I am, and that
okay.
tells me. And I actually have a note on my frame that says which way I need to turn the B angle if it needs to be closer or further,
Yeah.
because
Yeah.
that's what it just so I just have that because I can never remember which one to use, but I
Yeah.
just have a note there. But I just essentially make a wooden feeler gauge to.
I have that too. If too far, B, rotate this way. Too
That's
close,
exactly
B, rotate this way.
that's exactly what I have. I just have a label, a sticky sitting on my frame that tells me
I'm going
it's
to
like.
add the only caution is if you're only offsetting it 2 millimeters, but you've asked it to do a 3 millimeter depth of cut, you're still going to cut into it.
But not on the yeah
Not on
yeah
the
that
first cut.
not on the first cut.
Unless you're doing, well, if you're doing inverted facets, if you're doing scallops, then you might. But for these, you won't. So I'm 4 millimeters off. So let's set that Z to 0 here, and let's just do the same thing and see if we're actually 4 millimeters off. So, or close enough to it. And it does move back and move over to make sure that there's clearance for everything every time you do it, which is a little bit annoying. It'd be nice if it was smarter, but that also becomes harder.
but I think we've all seen a picture of Justin's probe as well.
Yes. Well, that got fixed in last month's update for the probe. So yeah, I mean, I think that that works. And from what Steve said, that's the way that he effectively does it. So, having 2 millimeters off, that seems like it should work. Of course, now I have to go back and I've got to set the the Z properly again.
But thank you for the demonstration and verifying that it does do that.
Yes.
So if you was just to hit home now, wouldn't it go back to the rim
Uh,
again?
it's going to always take the shortest path home.
Yeah.
Understand. Good way to break something.
Ask me how I know.
So you do want to make sure that you get to some appropriate positions first. So Z home, and then we are 1, 2, 3, 4 millimeters off. So I can go in just
Well, I'm going to try to remember that so I can learn from your previous experiments.
All right. So yeah, so there's been a lot of lead up into this, but let's say that's going to be good in this case. I didn't actually check my max point, but that's fine. I'm not too worried about that. What I'll do now is I'll rate this job. Oh, super advanced features. I know Steve had questions about these. I think I've answered them all. There are some important ones. The step size is because this is an X scan, every 0.5 millimeter, it's going to write out coordinates for how it's going to move. You can change this value so that you can put that to whatever value you want, but this B smoothing points will use however many points associated with that. So adaptive feed rates
Could you say
are
that again? Just that the B angle smoothing. It's still. And what ranges you typically use in there?
Yeah, so I've cranked these up over time. I started off like using 6, and that wasn't enough. There was enough jitter as it was going that it wasn't, I had to keep increasing that value basically until I had no jitter. Um, I think at 0.5, probably 50 is reasonable for this, but I've just kind of kept this default at 100. So there's not going to be there's quite a few points here, but it's going to basically be taking that average of I actually don't know I can't remember exactly how I've handled it when there aren't any points to the left of it, but it uses the center point, and then it takes some number of points on either side of that to just average what that angle will be.
Got it. Okay, good. Thanks.
Adaptive feed rates are for when you're making very shallow cuts, as we're going to start with this. You can make it go a little bit faster. And so I usually crank that up to about 3. So that will triple the speed for very shallow cuts. And it will scale based on, so a 0 depth cut would be a multiplier of 3. Though, right, you can't really have that, but that's effectively what it would be. And anything that is slightly deeper than that will be scaled by up to a maximum of 3, if that makes sense. All right, so I'm going to write this job first. So it's going to write out the facets. You'll see that showing up over here. These take a little bit longer to write because there's quite a few steps for these. Quite a few depth steps, I should say. And I'm going to open up the G-code file. So here's the file that's been generated now. I'll download that and we'll look at it. And I want to just show you some of the information that's in the header of the file that's important for this. So if we look at this, of course, that little zoom dot is in the way. Actually not. There it is. So this is what I want to point out. The max depth in this case, because we're cutting 4 facets on the piece, right? It's going to be cutting very, very deep. I think I closed my Inkscape diagram, but in order to try to make those flat at 4 sides, it has to cut very, very deep. But my bowl is not even 30 millimeters thick. So that's not going to work. I'm at a maximum. At the rim, it's about 21. It's a little bit less further in, so I need to adjust that value. So what I'll do here, I'll close this for now, is I'm going to just change this depth modifier and make this about 0.41. So this is now, this will say, okay, you're going to only go to 40% of that maximum depth, basically. And so I can write that job again, and it goes a little faster because it doesn't have to go cut as deep. And it'll write over that file that's already there. So you can see, I don't know if you noticed that, but the file size shrunk in half, basically. And if we download this, I'll just write over that other file, replace. And we look at this. The maximum depth now with the scaling is going to be 12 millimeters deep, 12.3 millimeters. And that's reasonable for what I have here. And you can see how many steps it's actually going to take. To do one of the 4 facets, it's going to have to do 170 steps to make it all the way through those. Is following me with that one?
Yeah, that makes sense.
Okay.
So, do you ever? I found that for inverted facets, the depth modifier, I'm using 5 or 6. Does that make sense? A whole number rather than a fraction.
You can use a whole number. I'm going less than, right? So
Right.
it's multiplying. It'll always multiply that value. So I'm trying to go to a smaller value.
Okay,
You're
because
trying to go to
you have a small number of I see what it's doing. I use if I'm doing 40 facets, it's
right.
making it. I want it deeper. Got it. Okay.
You want more relief when you're doing
Right.
40 facets because otherwise it would be just very shallow cuts. So you're
Okay.
trying to increase that value. Yeah.
Yep.
And the inverted facets that Steve's talking about is just this button right here. So if I click invert depths, it would change how it would, in this case, we're making flat. And instead of, in that case, it would make, well, I guess I can,
I
for
have
the,
one. I have one queued up on my monitor here. If you want me to show you one.
well,
Oh, there you go.
right, so that's the opposite of a facet. This is following a profile as well, but that's the idea is that you're making scallops instead. Okay, so let me go to this view here. That's going to be good for our G code. I need to make sure my router's turned on, and I'm just going to let it do a couple of passes. That's going to turn on automatically. And I think we're good. It's going to get loud, so I won't be able to hear you when you're saying anything, but I'll just let it go a little bit and then I'll do a feed hold and stop it. So, um, make sure that I'm at, actually, I'm going to rotate A little bit here because I've got my grain right there. I want to center a line on the side grain of this. So about there. And I always usually back it off a couple of millimeters before I start so that the router has time so that when it spins up, it won't be sitting or very near to the piece. And so I will click start. It's a little off right there. And I think you can probably see in this view here. So this is how it's making the cuts now. It's going to keep going deeper and deeper and deeper, and then it'll get to about this point, and that'll be halfway through, and then it'll get shallower and shallower and shallower in order to make a facet.
So that would actually do a full depth of cut at the maximum.
It'll actually be it'll be four passes at the maximum in order to get the full depth of cut because it's going to go up to 12 millimeters depth of cut. And
Okay,
I only
so
did 3 millimeters.
So 4 passes, so it's only going to cut 3 millimeters at a time. So for
The
the
maximum it'll cut at a time is 3 millimeters.
gotcha. So at the point here, it looks like you're close to 3 millimeters on that, so it would continue that.
Yeah, and what'll happen is in those passes where it's like say 3.2 millimeters in order to get to the final depth, the 3 millimeter cut will go slow, and then because I use that adaptive feed rate, that 0.2 millimeter cut will go much faster. And that just saves you a little bit because it will, it goes forward and back. If you tell it the maximum is 3.2, that 0.2 is you're barely taking anything off. You might as well cut it at a faster feed rate.
So Paul, was the edge of that cut there where you started, was it flush with the 205 millimeter edge?
It went a little bit in. So I'm right at the you might not see that in this view because I stopped this right at the beginning of the cut. Let me switch cameras here. Right? You can see that it's cutting the center of the bit is very close to because it's been rotated, but the center of the bit is very close to that 205 millimeters at the edge.
Yeah, I was thinking where it started cutting.
This is the position, the start cut position, even when it was here, right? At the bottom. It moves back to the same position every time.
Yeah. And you got half a blade to work with, right? Yeah.
Yeah. Um, okay. I don't know if that made sense or if there were things that were unclear about that. And there's striations in this. It'll actually get nicer closer to the middle, I think. And it's usually right at the edges here where you get more striations. And if I had this, oh, probably that view's not the better one. If I had this, I was a little bit off on the very first cut right here. I don't know if you can see that. It didn't cut. It was off the surface just slightly. So I probably could have done a better job lining up the B. But when it gets to about here, it should be nice and smooth.
But presumably the smaller width of the bit and the less the increments, the smoother it would be.
Absolutely. Yeah. And that's where I still think, Steve, I think you've probably done the most of them. So that's why I was asking about what you were doing for step over. So the smaller the step over, the nicer it's going to be, but the more time it's going to take. So
That's correct.
So, Paul, I don't think the UCF would have any trouble making that cut. Assuming that your step over was small enough.
yeah, well, that deep though.
Yeah,
Okay.
I can do like maybe 25% engagement of the UCF. So if you look at the diameter of it, 90 degrees
Uh-huh.
of the cut, as long as the step over isn't a lot, you know,
Yeah.
you
I guess you probably want the
15,000.
feed rate. You'd want the feed rate down though as well, I think, for
Right.
UCF.
And I usually try to do 15 thousandths or less per step over.
Uh-huh. Because the one thing, so that I will say that is a limitation of this, at least for what I've been able to code so far, is the B rotations. So the rotary axis rotations. I'm using G93s, which are inverse time mode, to try and get all of the axes as coordinated as well as possible. But you sometimes do have, if you have rapid transitions in B, there'll be like a quick flip of the B axis at locations, and that will the cutters don't like that because that I don't know if actually that's true, but that's what it seems like is that the cutters don't like doing that, rotating quickly while it's engaged in the piece.
Mm.
So, so G93 inverse time mode only works on two axes. So you're doing XZ, you're in the XZ plane doing G93s and rotating B independently.
No, G93 will do all axes. It's not two axis dependent. So G93s are just do this move in this number of inverse seconds. Right? Yeah.
Okay,
Minutes.
In whatever the time unit is.
Yeah.
It's messed up between metric and imperial and time.
So a G93, if a feed rate of 2 would be whatever the move is will take 30 seconds.
And it'll adjust all three axes.
All four axes actually. Well, three axes in this case, but if you were doing some kind of if you were following a profile, or the other thing I didn't show, you can do arbitrary rotations of the A axis for every pass. So it would actually do all four axes at the same time.
Okay. Something for some reason I was thinking it was like the arcs. It was a two-axis plane limitation, but I have to go back and look. I trust you.
Yeah, I know that in the firmware there were some bugs which got sorted out a couple of years ago where it wasn't doing G93s properly because it had to do with setting the rotary axes correctly. That it knew that you were talking about angles versus millimeters. But I think that's all been sorted. So to my estimation, it works how it's supposed to.
Okay, great. Yeah, no, maybe I'm just thinking back, like before that got fixed.
That might be. Yeah. Okay. I'll stop my share since I don't have anything. I've got to remember how to stop my share.
So Paul, on that piece that you showed us with the scallops, how did you get that A rotation on it for that pattern?
Yeah, let me show you. So hold on a sec. Which view am I in here? You're talking about this here?
Yep.
Yeah, so in the software, there's two things. So I'll describe them both. I was just mentioning this, but the first is A-axis rotation. So this is the number of degrees. You're seeing the software view, right?
Yep. Yep.
Okay. The number of degrees of rotation for each segment. So that is just a pure rotation. So if you say you wanted to rotate 20 degrees, you would end up having a facet-like thing where this would be rotated 20 degrees with respect to that axis. It wouldn't be flat across. So that's one thing. The other is this A rotation profile. So this is where you draw something, which would in the form of an SVG file that it'll follow that profile. And this is still yeah, okay, this is the one I have here. So this ambrosia test. So let me pull that up in Inkscape so you can see what that looks like. Move that up here. Of course, I have to find it. Where do I put those? I can't remember where those go. Scans?
Oh,
Oh,
there it
there
is.
it is. Yeah. So let me scoot that over. So that's that profile. Of course I got rid of it. So you can see if I input that profile, what it'll do is it will basically follow that from left to right in my piece, however I have it set up.
Yep.
And so it's to me it's still a little bit unpredictable, like how it's going to look when it comes out. But that's how you do it.
Can I just see that bowl again now that I've seen this profile?
Yep. Alt. Hold on. Let me do overhead. So I'll do side by side. Let me scoot this over.
So that profile is then also following the X scan to wrap around towards the base of that bowl as well.
That's right. So I think you can see it, right? Like that's the right side of that, and then it goes kind of straight, and then it goes up, and then it comes back around like that. And it what it does, honestly, it's been a little while since I wrote that, so I'm trying to remember exactly how um it uses whatever in this case, this would be the Y dimension of this. So what is the Y? Height in this case is 28.3. So it knows the length of the profile that you have. And so it can determine, and because you know what the diameter is at the end here, it can determine how much rotation you have to have in order to, how much A rotation has to go into all of those to meet up with the number of segments that you have for that particular profile. I think that's
I,
how
I'd assume you had a depth modifier that was greater than one on that.
Yes, I don't remember what it was, but yes,
Okay.
this was definitely greater than one.
It looks like it might have been 4 or 5 or 6 or something like
That
that.
it was yeah, it was probably that. So what I often do is I'll just do it I'll write the G code at a depth modifier of 1 and see how deep it's cutting, and then I'll look at my rim and say, how deep can I go? Okay, then I'll multiply that by 3 or something, or 4 or 5.
So if you
And
wanted to
just start
repeat
it
that
in.
on the inside, how would you go about doing that?
That's going to be a lot harder on the inside. I actually don't have that built in. So to do insides, you're almost always, rather than doing an X, right? So this was an X scan that went this way. To do insides, you have to do a Z scan. So you'd be scanning in Z like this. I did add the ability to be able to follow a profile on a Z scan. The problem that you run into is that in order for the tool to follow that, like when you're on the inside, right? The tool's going to have to rotate a whole bunch in order to, here, let me just go to this. Uh, no, this, right? That tool is going to have to rotate a lot to get onto the inside of that bowl mounted here. And so I'm going to run out of room trying to move the tool all the way back here to get on the inside of the bowl. So with shallow things, it works okay. With deep things like this, I don't think you could do the inside.
So this goes back to one of the advantages of the universal cutting frame, because you can be making a cut when the router itself isn't actually normal to the surface, but the
Yeah.
cutter is cutting on a tangential path. And so
Yeah.
that's where I think there's going to be some, we're going to cross over into some weird worlds with that.
And that was a bit of the email exchange that we had, you and Ed and I had, that what you were talking about there. Yeah.
Exactly.
Yeah. I agree. I think that could be, I I still don't like my universal cutting frame that much yet.
Well,
I
I think Fred might make heads for that will be a little bit more robust, but we'll see.
okay.
So, Paul, when you're doing talk about scanning the inside of the bowl and you had run out of room, could you scan from the other side, from the far side and come to the center doing a negative scan?
Um, I don't know. Possibly. I have not done that yet.
Yeah, and then going back to Ed's question, that's going to be because what Ed's trying to do is make basically a concave cut that matches the convex cut on the outside, and then also follow along your A-axis
Yeah.
profile. And
Yeah.
that's going to get really ugly.
That's gonna be hard. I mean, I think you could probably work it out for the shallow thing. Like what thinking about it for me, the shallow things would be okay to do. But doing anything with depth to it is gonna be hard. Yeah.
How did the early tests with the ribbon bowls, how are you doing that? Was that an internal scan or
Yes. Yeah.
okay?
For Pat stylable.
Yeah,
Yeah,
yeah.
I don't have any of those near me. Yeah, that's an internal scan. Those got a little bit hairy because I was using like that end mill there, but in order to be able to reach all the way around. I was having to have that end mill stick out basically as far as I could in the collet to like have it be really long. And so it was there was a lot of vibration coming from that.
Yeah, I don't in ornamental turning we have a thing called a right angle cutting frame too that you can put a bit in, and so you can be inside the vessel but cutting perpendicular to the tool travel, um, if that makes sense.
Yeah,
Let me see.
yeah.
Let me see if I can grab one.
Paul, I just texted you a photo of my internal right angle cutting frame.
Okay. Let me remove my whatchamacallit here. There we go. Okay, yeah. I remember seeing that.
Paul, if you'll allow me to share, I could show you a piece that I recently finished that showed the angles on the, the rotation on the facets and
Yeah,
the
let me turn that on.
depth modifier.
Okay, I think I've turned sharing on now. Yeah, Pat, I see that.
You guys seeing that?
Yeah.
Yeah.
So that's showing the that's 40 facets around a curved rim. It's about 12 inches in diameter.
Can you show the front view
I
close up?
can't. Let me just trying to figure out where I have other views. Hang on a second. I have to stop sharing. Hold on one second here.
Yeah, the one thing of going around the curve like that is that you use up a lot more X real estate, right?
Yeah,
Because as you get along that curve in the front, you got to rotate B the other direction, which means you got to push X further negative in order to
yeah. So that's the front and
start sharing again.
oh, are you seeing the front? I guess
Yeah.
it's okay.
Yeah, that's cool.
So
And so
there's no cuts on the inside there though, is there?
no, but the rim curves the
Negative. Yeah.
the rim curves negative, so it comes around onto the inside. Uh, and then I can show you a side view here too.
I'm gonna have to get a bigger waste bin, I think.
So that's it. So it's about 12 inches by 2 inches high.
Yeah, that's cool. And how many
Um,
how many is that?
40.
Yeah.
And that's one with a depth. I believe the depth modifier was 5 or 6 on that. In order to get those, I actually cut this twice. I did it all once and they were too shallow,
Mm-hmm.
and particularly where they came around onto the top of the rim. So I just left everything in there and re-homed it and just ran the program again and just cut the same bowl a second time. So, but anyway, just showing that, and I believe that's a 20-degree angle on the face
Straight
there.
angles.
Yeah,
Wasn't following a profile, just straight angle.
right. Yep.
Did you do that on the lathe engraver?
Yes.
So were you pushing any limits on that 12-inch bowl going negative?
Nope. I didn't have any trouble at all with that. It just no. And I've actually done one a little bit deeper than that, and without any trouble at all. It's just that sometimes you just have to move things around, but no, I didn't have any trouble at all.
Hmm.
I'm doing some.
I get what Paul was saying. The farther you go around there, the more X axis you're going to use up
Yep.
Yeah.
to
I'm
get around the corner.
doing some mirror frames right now. So if the back view of that, somebody in one of our club show and tells looked at that and said, if you put a mirror in there and made a wall hanging out of it, it would it would sell. So anyway, so I have some now that with an 8-inch mirror and a they're as big as I can make them on the frame without going over to my lathe, and that's actually one cutting right now. My first one's actually in the machine right now, cutting as we speak. So,
Cool.
but it's essentially that same thing.
Yeah, the one person who's pushed the axis limits, Michael Early's, he's using it for doing laser lines for basket illusions. And because he's got large curves in his pieces, I mean, the pieces are fairly large to start with, but lots of curves to them. He's like basically gone all the way to the max limits that you can do. So he, at some point, I've sent him parts to make an extended X-axis version. So it'll actually be a one meter rather than a 500 millimeter, it'll be a 1 meter X-axis to be able to swing around curves all the way for larger things.
Paul, if you put it on the lathe, are you still bound by the 15 inches or so, whatever it is? Does it, even if the lathe has a larger swing, are you
No, you just have to space the tool out so that the tool's on center.
okay?
That's all you have to do.
I bought the parts for that when I got mine, but I've never put it on my lathe because I just never want to tie up my lathe for as long as it
Yeah.
takes to do these things. But I'm thinking about some of the wall hanging type things that may warrant a larger application.
And no sanding on those, of course.
Um, there's lots of sanding, but I'm actually trying to figure it out. I've tried one here where I ran it once and chopped got the bulk of the wood out at a relatively slower speed, and then ran it a second time with a much finer grid and step over, and it allowed me to run it really quickly, but it kind of offset and got some of the ridges out and made the sanding easier because there is sanding. I mean, with all those and with that you can, yeah. I'm still sand. I'm not. I guess I haven't joined the ornamental club yet, so I still sand. So, Paul, you had mentioned in one of the earlier users meetings about drivers, which allowed. Oh, I think you said more
More
take
power, wasn't it?
more
Yeah.
power or something like that. What?
Yeah, those are
Motors.
the stepper motor drivers, so the things that are actually controlling the motors, you can put in more powerful ones. That will increase the speed that you can go, so the feed rate, as well as potentially the depth of cut. So those are the TMC 5160s are the more powerful ones. The ones that come stock are the TMC 2209s.
So, what would be involved in making that change?
You have to open up your control boards, take out the old stepper drivers, put in the new ones from wherever you got them, and then you also have to do so there's a couple of there's jumpers. So you've got to if you look in the hardware bag that had the blue box, there was a whole bunch of these little two-position jumpers. You got to change out where those jumpers are and then put in the new chips. Basically they just slide right into the same spots, and then you got to update the firmware, which is that you need a micro SD card. I have the firmware compiled. You just put that firmware onto that micro SD card, pop it in, turn on the power, wait 30 seconds, and then it'll have the new firmware for those drivers.
Sounds too complicated.
What was the name on that driver again?
The more powerful drivers are the TMC 5160s.
Is it
And
TMC or TMZ?
TMC. C is in cat.
5160.
Yeah.
And you need to
I mean,
change your stepper motors too.
no, these NEMA 23 stepper motors will handle it. So, I mean, they'll get warmer than they do now, but they're still well within range for the NEMA 23s.
how does the how does the firmware change or modify the current for the steppers?
It doesn't modify the current directly. It's just that the the 5160s use SPI to communicate with the drivers, and the 2209s use UART to communicate. So you have to tell the firmware which drivers are going to be used. So that's the only change in the firmware is you just say I'm using different drivers.
Okay. Um, Backing up to the topic we were on
Yeah.
a while ago, this is a motorized cutting frame with an AXA style tool post holder or quick change tool post holder. But then with a bit, I just stuck a proxy in the end, and the bit sticks out at 90 degrees. So this can be going in, and it's cutting on the side instead of cutting on the axial end or like a regular cutting frame. So I don't know if that's like the one somebody else said they sent you an image of, but that's a right angle cutting frame.
It has similarities. The Pat's yours is actually going um rotationally orthogonally to well, I guess that one is too.
Yeah, it's 90 degrees. The big
Yeah.
difference I see with yours, it has a Gilmer belt, and my belts tend to wear and slip and all, so that's a nice addition.
Well, it's an old version. Paul Clare, whose lathe was the first ornamental lathe I got, he used a lot of the timing belts. These are all whatever it is, MXL version tooth belts, and it was a pretty clever way to do it back in the day. So, but they're all on universal motors that are way too loud to be working with in the shop all day.
Mm.
But then, while you guys were talking about something else, Fred called, and let me just share my screen. He has a prototype that he just sent me a couple pictures of, and so this is the brushless motor. This is a 55. Let me grab mine because it'll make more sense to see the face of it. Dragging wires behind me because everything's hooked up. But anyway, this motor happens to have some face-mounted screw tapped holes, and so Fred just made a carrier plate that sits on top of the rotary, and this gives it a little bit of. Our whole thing was trying to figure out how to deal with getting to center height for
Yeah.
stuff, and so he just put slots vertically on this frame that supports it. And then this screws right into the base on the lathe engraver, and you can pick a couple of holes and move it forward or back a little bit too. But it gets the motor body back quite a bit further and gives us a little bit of height adjustment without anything that's overly complicated.
Yeah, I like that. That's nice.
So that's sort of a preview. We'll see where that goes.
Is that quieter than the universal router?
Much quieter. Here, let me find a plug. I've got it in my hand. I can show you, but Dale's also on the call. And Dale.
Yeah, I've run mine. About the only way you can tell the cutter's going around is to actually look at it.
Wow.
It's pretty much how quiet they are. I run a vacuum in the workshop that with that on, you don't know the machines weren't running unless you see the chips flying.
And what motor is
the
it?
one, I think the one big advantage of, I don't know if it's a big advantage of the brushless motors is routers aren't designed to run for long periods of time without stopping. When you think about the guys that first use these routers, or they're carpenters who will make a 10-minute cut, and then the router will sit for an hour, and then they pick their router up and they'll make another 10-minute cut. Whereas, when you get into this kind of work, sometimes you're running that router for 6 straight hours, and they're just not, the bearings and the motors aren't designed to do that. So spindles will run almost indefinitely. I mean, they'll run forever, basically. And I think some of the guys on CNC machines have found that using these routers doesn't always work. I mean, they fail, and they end up, spending, after they bought 2 or 3 routers, they end up buying a spindle for them.
So I have my AirPods in, so I don't know if the sound will be the same, but here's this spindle. I don't know if you can hear, that's it up to my AirPods. I don't know if that's coming through, and it's variable speed, so it can go down, nearly a stop, and that's full speed. And it's nothing like having a universal motor in front of your face. It's a completely different beast.
And it's just a standard air-cooled spindle?
Yeah, it's air-cooled. It's got a fan in the back. And I'll put a link in the chat. That's the easiest.
So I've used I've used 2 of them before. One, when I was working on the 12-inch lathes to find something that would actually work with that. So I used the brushless DC spindle for that, and just didn't have the oomph that it needed for relatively deep cuts. And then the other one that I bought was okay. It's just that, I mean, I think you got to buy like 3 of them and then get one that doesn't have problems with run out, maybe, or maybe I'm just unlucky. But I bought a couple and it was like terrible run out.
And that was Dale's comment, was he didn't think this had enough oomph. This is a 500 watt, 55 millimeter diameter body. And so, I don't think it's bad to have more than one, depending on what you're doing. And maybe there's another one that's more wattage and has a little more oomph, but compared to using a universal style brushed motor, it's, noise wise. And like Dale said, they're designed to run forever. They're not a 10 minutes on and you're done kind of thing.
Right.
So,
I mean, I was going to just kind of bite the bullet and get one of the square, I think they're the square 80 millimeter, 2.2 kilowatt spindles with a VFD, right? That you can get a 110 volt one, which I'm set up pretty permanently. I could just kind of put that in, and that would be the one thing that I needed. But I haven't done that yet.
Yeah, the one that John and I bought, they're about 100. I think it was $150 for the spindle, and you can't push them like you do a router. That's the only disadvantage. They just don't have enough power to plow wood like the routers do.
Right.
But I didn't see much vibration in my cuts. So of course I wasn't running it real hard either. I don't tend to run the things very hard, because it doesn't matter how long it takes, if I've got other things to do in the shop, and because it's not really abusive to have that thing running while I'm doing other things. Like a router, routers are just loud, and the noise just gets,
drawback. Yeah,
it gets to you after a while.
So I just put this in the chat. It's $152 right now. And so depending on what you're doing, I think it's a decent spindle for, not for making horrifically deep cuts and doing stuff in multiple passes, but it's a lot quieter.
Yep. Mm-hmm.
And I haven't looked since this to see if there's a slightly higher wattage, similar form factor
Rat Motor makes a 600-watt one, I believe. That's RA. I think it's RATT. I'm fairly certain.
Yeah, I think I looked at some of those, and the ones I looked at didn't have very good ratings on them, or reviews, I mean. And
Yeah.
I was a little bit leery of them. This one didn't look too bad, so that's kind of why I went with this one.
They have another one, 750-watt permanent magnet brushless servo motor, 6,500 RPM. And it's a square body, kind of like you were talking about. So still flange mount.
Mm-hmm.
I think if the routers do fail for you, you might seriously look at switching over to a spindle.
It's interesting. The specs on that, although it's listed as 500 watt, it's actually listed as 600 watt in the specifications.
Yeah, there was that, it's all Chinese, you believe the specs if you want to, but the advantage of it is there's the 2.2 kilowatt. Wrap motor also has the 2.2 kilowatt with the VFD.
So another option is to use an AX8 dual post and an overhead motor. So here's the rotary table that I'm working on.
Mm-hmm.
So, and they can set a drill frame or a UCF on the center line with it.
Cool. And that's for your mini. This is what are you calling this, Ed? The mini lathe or what's
Mini lathe, yeah.
Okay.
Yeah, but the mini lathe got bigger when he realized it wasn't going to cut it.
Yeah. And it's kind of a mid lathe now. Yeah. So I just started printing the parts for it this week.
Cool.
But I'm kind of sitting there sketching things out, saying, a meter by a meter isn't bad. If you can get all the way around and wrap around the edge and rotate the tool around, I mean, you're opening doors with the software that haven't really been able to be, used before. So I don't think there's anything wrong with having a meter by a meter of travel.
It's,
Or
it
a
should work.
table.
Yeah.
Yeah.
Steve, the one other thing about the TMC drivers, um, if you want to do that upgrade, buy them and just bring the board to Raleigh, and we can do the firmware update there.
Okay. Sounds good. Where do you buy them?
Amazon, AliExpress, kind of
Okay.
anywhere. You
All
just
right.
need to make sure that you get the same form factor, which I don't remember if that has a particular name or not. Let me just do a quick Amazon search, and though
I was
I'm not saying that you should buy from Amazon.
I was doing the same thing, but there's a weird version of the 5160s. I was looking at them for something else because I wanted to still be able to do serial UART. And there's a version of the 5160 that does that, but then you just went to the straight 5160 SPIs.
Yes. I think that's what you'll find for most of them are the SPI versions, I believe.
Yeah. The one I have saved for later that I was going to buy are yours, the 5160 SPI and step direction mode with a heatsink, 4 of them for $70.
Okay, so in my experience, um, the this would be the best. The Big Tree Tech makes the best drivers that I've come across. So let's see, chat. Um, those are 4 drivers for $50, and that's the right form factor to fit into there. And those do SPI.
And how many of those do you need?
You need 4 of them.
Is that the one you bought?
Me?
Yeah. Because
Uh, this is
there's,
newer. The ones that I have are probably 5 or 6 years old.
yeah,
So
I
they,
went to the Big Tree Tech to look at the website because like yours says V1.0. I've got one that says Pro instead of V1.0, and it's also SPI mode. And they're, saying Octopus Pro, Octopus SKR, 3EZ control boards, blah, blah, blah. Same, it has all the same text, but it's the 1.0 versus the Pro, and I'm not sure what the differences are. I remember
um,
having to go to Big Tree Tech to dig through it.
so let me see if I can find a pro.
Here, I'll give you the link
It
to the
looks
one
to be
I'm.
the fourth one over says Pro on that Amazon link for $70.
Yeah, I see that now. To be honest, I have no idea. I mean,
Yeah,
I
that's
don't,
all I'm saying is I was asking if these are the ones you bought as opposed to, um, you know, I was, um, I had to go digging around on the Big Tree Tech.
yeah, mine are from Big Tree Tech, but they're going to be again so much older. They don't even make the ones that I have in mine. So I would probably, I mean, I would just go with if you want. I think the non. Sorry, I got a sick kid at home who's trying to get treats. I would just go with the 5160T V1.0. $50. They're gonna do what you want to do.
All right.
Yeah, but there's delivery on tomorrow for the Pro.
Okay, well, if it's all about what's important to you.
I think, but I think to Paul's point, the important part is that they're SPI and they're the right form factor. Just make sure those two
Yeah.
jive.
Yeah, because they do make versions of all of these drivers now that are like I don't even remember what that interface is called, but they're like graphics cards, right? You stick them into linear slots as opposed to having pins. So
Mm.
Yeah, and they did that because they wanted to still match the old Pololu footprint,
yeah,
but be able to get a vertical standing chip, and so they just put the edge slots in there, and that's Big Tree Tech's new form factor for.
yeah, exactly.
All right. So, Paul, what you're saying though is to order the ones that aren't the Pro.
I would, if I was ordering them, I would order the non-pro because I have no idea what the pro is, and it costs you $20 more, and I don't
But
think
it's
it's going to do anything extra for you.
but it's professional.
Well, I guess if you're selling your pieces, then you're a pro, and
That I need it.
yeah,
Well, it costs $20 more. It must be better.
yeah.
The only thing that I remember from when I was going through it was the Pro. I was looking for something that would also play well with step and direction controllers because I was going to do something with a Gerbil board. And, so it was some things can deal with SPIs, some things can only deal with step and direction. And I think the Pro was jumper settable to be either. But I don't remember I just had that in my saved from when we had gone through this conversation when Paul first tried the 5160s.
Uh-huh.
All right.
Actually, if you
Well,
go on that Amazon link and it's looks to be one, two, three, four, five, six images down, it shows the differences between the two.
On the pro one or the other one?
For both of them. It's got the just the straight number and it's got the Pro number.
Oh, I see it now.
And I'm trying to
Oh, it
see.
goes up to 56 volts, which doesn't matter since we're running at 24 volts. Oh yeah, there you go. Operating modes, John. You had that right. So you can do SPI or step direction with the Pro. So you will not gain anything with the Pro for, with the lathe engraver.
got it.
Good discussion.
Yeah, good to know those things.
There's too much crap out there.
For sure.
All right, Paul, I may do that. I may just, so what do I need to bring? I just need to bring the box.
Yeah, the control board.
Okay.
So just disconnect all the wires and bring that board, and we'll pop in an SD card and get the new firmware in there.
Okay. Great.
So how
All
many
right.
kits are you taking to Raleigh?
I'm gonna have 6 of the pre-built kits. That's I could probably get a couple more done, but that also is like fitting everything in my truck, and I'm taking my mom with me too, so I'm not gonna have quite as much room as I would have otherwise.
Oh, so she's going to be working in the booth?
No, I'm gonna drop her off at my brother's house in North Carolina before I go to Raleigh. So
I'm driving down too if you want me to carry things down for you.
oh, cool. Thanks, Pat. Um,
What are you getting in, Paul?
I am going to get in very early Thursday morning.
Okay.
So I've got to drop off a piece for the gallery at, I think 9 is when the latest that they want you to drop it off. So and then I
Okay.
check in at 11, I think is when my check-in time is for the booth.
Okay. All right.
And Paul, you're going to bring an extra couple of parts down that I can buy from you too.
Yes, I have those all stashed away, and I have a invoice for you for those. So
Yeah, good.
I can't remember what I put on. I think it's probably like 75 US or something along those lines.
Perfect.
All right. Well, I don't know who's if we've had any of our new people sticking around, but I appreciate everybody coming in. And again, if you have any questions, again, I'll be doing this monthly. If you're not on the email list, let me know, and I can put you on there so that you get these messages monthly. Um, I'll also I'll probably be reaching out to some of you, Pat. We talked about a few things, flyers, so I might be asking you some questions about that. And everyone else who's going to be in Raleigh, I look forward to seeing you there.
Yeah, Paul, this is a great meeting. Thank you very much for doing these. It's really helpful. One thought you may do on the YouTube channel is to just maybe in the comments put just a sentence or two, like this one would be facets or something like that, a discussion about facets or something. So, going back and trying to figure out what was on them, or maybe we could just put that in there in the
You
comments.
mean
But
with respect to like these monthly videos?
yeah,
Yeah.
Yeah.
What was the basics? What was the main things we talked
Right.
about?
Justin
Three
had
or
done a
4
great
items.
job of that at one point and done the timeline thing. So yeah, I mean, I can go through and do that as well. Or if anybody else wants to throw those things up, if you're watching it, um, that would be cool.
Is that searchable then in the comments?
Oh, that I don't know.
Because I
I can
know I've gone
always
back
take
trying to find out, hey, we talked about this in one of the meetings. Now, which meeting was it?
Hmm.
I can always go back and take the comment if somebody put like outlines what's in the videos. I could just copy that comment and put it in the video description, which I think would then make it searchable.
That would be, yes.
Yeah.
yeah, like for this one, just cutting facets or something like that would be just
Yeah.
really helpful. But no, this is I mean, as many as I've done, having you go run through that again today and have the opportunity to just ask questions is it's just really helpful. We appreciate your time doing this.
Yeah, this
Yeah.
is just, it's fantastic that you're taking the time to support us this way.
Yeah, I'm happy to do it. I love to see when people make things with it, and um, I continue to look forward. Like I'm really glad that Justin was able to write a plugin now, so it's not just I want there to be a community involvement in this. So everyone else coming and asking these questions is also very helpful. So
Yeah, no, really comes down to this isn't a plug and play type of device. This is something though you got to get into and play with, figure out, use the community. I know I had one friend who was asking me about it, and he's looking for a plug and play, and I'm like, well, this ain't you.
yeah, that's definitely not that. Yeah, there has to be the effort put into figuring out how it works. So I'm just trying to make that as easy as possible, um, while recognizing that it's not ever going to be plug and play. At least I don't see that happening.
One of the things I was doing when I was first starting to play with it quite a bit was going through some of the basic stuff was how to I wrote a little quick how to in Word or something like I forget what I used, but I haven't kept up with that too much. Plus, I've been too busy. But just having that to reference back to has helped me quite a bit.
Yeah, I do apologize that I'm just terrible with documentation. I mean,
But when that's
we
like you said,
started this
community.
whole meeting with priorities, and I like doing the software. The documentation part of it, I'm not good at, and I just acknowledge that. So
It comes down to the community. We can all be a part of that.
yeah, yeah.
Well, and
And
having the Discord available too. I mean, you pop a question on there, and minutes later you have an answer. So that's really helpful. But
it's incredibly helpful. Sometimes we wonder if Paul's doing anything else but watching Discord.
I assure you I am. It's just that I happen to have it on all my devices. So
all right. Well, thanks, Paul.
all right. Well, thank you, everybody. And I'll see
Guys.
some of you beginning of next month. And also, late June, we'll have another meeting. So I'll let everybody know about that.
Great.
Thanks
Awesome.
again, Paul. Good
Thank
luck
you.
at the AW.
Thank you.
Thanks.
All right.